Hi everyone, welcome to all of you on my YouTube channel. I am Ankit Mishra. I am continuously teaching for the GATE Chemical Engineering from last 5 years. So here I am coming with PYQ series of all of these topics that has been asked in the GATE. So already I have completed distillation, mass transfer, humidification, and here I am going to start. I have also started drying, and this one is the second lecture of the drying PYQ. So you can see already I have discussed lots of questions that has been asked in previous years. So till 2000. Uh, 8 I have already discussed the question. Now I'll be going to talk about this question, and this one is just a match the column kind of questions from drawing. And this question, you can see there is a curve that is given to you, that is relative volatility versus moisture content, that is kg in water per kg of dry solid. And the equilibrium moisture curve for a solid is shown below, and the total moisture content of the solid is x is total moisture content, and it is exposed to air of a relative volatility humidity h in the above table below. So you can see you have to match the group 1 to group B. So when we talk about this curve, you can see that when equilibrium moisture content, so your equilibrium moisture content, so from here to here it work as a equilibrium moisture content, that is your x star. So for your P this will be 1, and for bound moisture content, so this will be your bound moisture content from 3. So for bound moisture content that will be 3, and unbound moisture will be this one, and unbound moisture will be 4, and again free moisture will be your 2. So this one is called as the free moisture content. So if you match the column, then you can see your option B will be your correct answer. Okay, this is just a simple question from the graph, and this is the basic fundamental concept of the drawing. That's why you should know these things. Now moving towards the next question, and 7.8, and the question says that a batch of 120 kg weight solid has initial moisture content 0.2 kg. So x1 is given to you, that is your 0.2, and the solid area is exposed this one. So you can say that ss divided by a, that is equals to 1 upon 0.05, that is equals to 20 kg per meter square. The rate of drying curve, drying curve is given to you, and you are supposed to calculate time required for the drying in batch to a moisture content of 0.1 kg. So the final moisture content is given to you 0.1 kg. So you are supposed to calculate the time theta, that time required to reduce the moisture content from 0.2 to 0.1 kg of water per kg of dry solid, and all of these things are given to you. So from here you can see that critical moisture content is given to you 0.25 from the curve, and obviously constant drying rate at the constant rate period is given here is 1.5 approximately, something like this from the curve. Okay, and if you see, so you are supposed to calculate reduce the moisture content from 0.2 to 0.1, something up to here. Is that clear? So when we talk about theta in a falling rate period, so you can write that formula is ss by a and c into xc minus x star ln, obviously uh, uh, अभी x1 minus x star minus x1 minus x star divided by x2 minus x star. But here generally in formula xc used to be equals to x1, but here it is not a falling rate period. You are supposed to calculate from 0.2. So if you would have told that calculate the falling rate period, total time required in falling rate period, then falling rate starts from here 0.25 moisture contents. But here the question is different, that's why I am assuming x1 and x2. So now you can write the value of theta, ss by a that is given is 20, and nc is given as how much, so that is 1.5, and that will be in hour, and x1 is your how much 0.2, and x star is 0. So multiplied with ln 0.2 divided by 0.1. So the value of theta you can get from here is 200 divided by 15 multiplied with 2 divided by 10 into ln 2. So if you calculate this value, you can get theta is equals to 8 by 3 ln 2. So let's try to calculate the value, how much value you are getting for the value of theta. So this time is for the falling rate period, but falling rate is not here you are supposed to calculate these things. So once you'll calculate these things, you will be getting answer is 2.31 hour. That clear? Okay. Then moving towards the next question. The next question says that consider drying operations shown in the figure below for a solid loading of 50 kg per meter square. So here you can say that SS divided by A, that is given 50 kg per meter square with the constant rate of drying. So constant rate of drying is given to you 5 kg per meter square hour. The falling rate of the drying is linear with the moisture content, and X equilibrium is also given to you 0.005. Critical moisture content is given to you, that is 0.1, and the drying time required to reduce the initial moisture content of 25% to a final moisture content. So initial moisture content is given as 0.25 and final moisture content x2 is 0.02. So xc is given to you, that is 0.1. Is that clear? So again, initial moisture content would be lying somewhere here, x1 equals to 0.25, and final moisture content, let's say here, is 0.02, and x star is given 0.05. So from this curve you can see there is a constant rate period, and this one is the falling rate period. So you have to write the formula and you have to calculate the whole time. So if I'll write the formula, theta is equals to SS by A and C, and you can say x1 minus xc plus xc minus x star ln, obviously xc minus x star divided by x2 minus x star. So if I'm talking about x star, so that is x equilibrium, right? Equilibrium moisture content. So let's try to substitute these things. SS divided by A, so 50 divided by 5. So you can write here 50 divided by 5, and x1 is 0.25 minus xc is your 0.05 plus 0.05. Sorry, the value of xc is 0.1, right? xc is your 0.1. So you can substitute this value here. 0.1 minus x star is 0.05 ln 0.1 minus 0.05 divided by x2. x2 is the final moisture content, that is 0.02 minus 0.05. Once you'll calculate these things, you will be getting this answer. So let's try to calculate this value first. So 0.02 minus 0.0, x star is 0.05, 0.005. Here it will be also 0.005, right? Plus so once you will do the calculation, you will be getting answer is 3.25. Is that clear? So this question was completely based on this formula. If you know this formula, then definitely you will be able to solve this concept. Okay, now I'll be moving towards the next question, and the question says that a wet solid of 100 kg is dried from a moisture content of 40 weight% to 10 watt%, and the critical moisture content is 15 weight%, and xc is equals to 0.15. Equilibrium moisture content is negligible, so x star is 0. all moisture content is on the dry basis, so x1 is equals to 0.40 and capital X2 is equals to 0.10. The falling rate period is linear, so theta 1 is in the constant rate period is 5, and the duration of the falling rate period you are supposed to calculate. So x is there, so if I'll plot this curve something like that, you can see how this will look like. So there is a constant rate period and falling rate period is also a linear, and equilibrium moisture content is negligible. So till this particular point, this will be your xc and this is your x star, and your x1 is 0.40 and xc is given 0.15 and x2 is equals to 0.10. So from here to here, so let's say I'm assuming theta 1 is this one and theta is the falling rate period, so this is n, and the drying rate is constant rate period nc, that is not given to you. Okay, it's fine. So first theta 1 is given to you, that is equals to 5 hours, so I can write theta 1 is equals to ss divided by ANC and obviously x1 minus xc. So theta 1 is 5 and I can calculate from here ss divided by ANC, and x1 is 0.40 minus 0.15. So what is value of ss by ANC? So that will be equals to 5 divided by 0.25, so that will be equals to 500 divided by 25, so that is equals to 20. Right, now when it comes to falling rate period, the formula of falling rate period theta 2 is equals to ss divided by ANC, we have already calculated, and obviously xc minus x star ln xc minus x star divided by x2 minus x star. So theta 2 will be equals to 20 into xc is 0.15, x star is 0 multiplied with ln 0.15 divided by x2 is 0.10. So once you do these things, theta 2 will be equals to 20 multiplied with 0.15 multiplied with ln 15. Is that clear? So once you will calculate these things, so from here you will be getting answer is 8.124. Is that clear? So sorry, I think I have done something wrong here. So it will be 1.5 only, right? So let's try to calculate one more time. So the value will be 1.216 hours. Is that clear? So all of these questions are only, you can solve this question if you know this formula. So all of these questions are on the formula basis. Just you need to understand what sorts of parameters you need to calculate here. Okay, so now moving towards the next problem. This question says that a fiber board sheets having dimension is given to you, is being dried by suspending in horizontally in a current of hot dry air. The edges are insulated so that drying takes place from only top and bottom surface. So let's say if this kind of solids are there, so here you can see that drying is taking place from top and bottom surface only. So if I am making this one is green, so drying will take place from this place and this green surface only. So if I want to calculate the area, so area will be equals to 2 into 1.5 into 2, right? So that is equals to 6 meter square, and the weight having 16 kg with initial moisture content of 60% loses at a constant rate. So x1 is given to you 0.60 and it is losing at a constant rate. So critical moisture drying rate at constant rate period is given to you 1.5 into 10 to the minus 5 kg per meter square second until it reaches to x2 is equal to 0.30. All the moisture content are on the dry basis, the time required for the drying at constant rate period. So it's very simple question. So directly we can write formula theta is equals to ss divided by ANC and obviously x1 minus x2, right? So theta, and what is ss? So you can see that the weight sheet containing 60 kg weight. So if I am talking about total weight is 16 kg and this is the weight solids weight. So what is SS? SS will be equals to 16 into 1 minus moisture content in X1, and capital X1 is given to you 0.60. So if I want to calculate capital X1, so I can write X1 divided by 1 minus a small x1. So a small x1 can be written as capital X1 upon 1 plus capital X1. So you can see 0.6 divided by 1.6. Is that clear? So after doing these things, you can calculate what is SS, that is equals to 16 multiplied with 1.6 minus 0.6 divided by 1.6. So that is 16 into 0.6 divided by 1.6. Sorry, this will be equals to 1. So once we'll calculate, this will be 10 kg. So you have calculated SS is 10 kg. So I'll substitute here 10, and we know the area, that is equals to 6, and NC also we know 1.25 into 10 to the power 5. So I'll substitute here multiplied with X is 0.60 minus 0.30. So once you do the calculation, so you can get 1000 divided by 125 multiplied with 6 into 10 to the power 5 divided by 30 upon 100. So you can calculate something like that, right? So you can get 4 into 10 to the power 4, and what is the unit here? So second, you are supposed to calculate in hours, so this will be in seconds. So that is equals to 4 into 10 to the power 4 divided by 3600. This will give you in hour. So you can say 4 into 10 to the power 4 divided by 3600, and the value you are getting is here 11.11 hour. Okay, this is a very simple question based on the formula of constant rate period. That's it. Okay, so now coming to the next problem, and here the question says that a weight solid, this question is asked in GATE 2022, and here we can say that a weight solid containing 28% moisture based on bone dry solid. So here X1 is given as 0.20. In a dried and dried dryer, the critical moisture content of the solid XC is also given to 0.10. The drying rate in constant for the first 4 hours. So that is theta 1 means drying time is given to you 4 hours in constant rate period. Then it is decreasing linearly. So something like that, this is happening. So if this is X and this is N, so sometimes it was drying with the constant rate period, and after that it starts falling like falling rate period with initial value in the next 1 hour. So from here to here, so theta 1 if I am assuming is 4 hours, and in next 1 hour it is for getting dried in falling rate period. At the end of 5 hours of drying, the percentage of moisture content of the solid is, so you are supposed to calculate X2 is equals to what, and you have started drying from X1 is equals to 0.20. So XC is given to you here 0.10, and here somewhere X1 will be there, that is 0.20. So you are supposed to calculate X2 only. Okay, so okay, that's a very simple question. So total time is given to you 5 hours, and that includes both drying both constant rate period and drying rate this period. Okay, so when I am talking about theta 1, that is 4, that is can be written as SI divided by ANC and X1 minus XC. So 4 equals to SS. So what is SS? We don't know. SS divided by ANC, and X1 we know, that is 0.20 minus 0.10. And when we talk about the falling rate period, that is 1, I can write SS divided by ANC. And again here you can see that the equilibrium moisture content is not given, then you have to exclude the equilibrium moisture content from the formula. So I can write XC is equals to 0.20 ln 0.20 divided by X2. This is the final moisture content. This will get cancelled out, and finally you can see that 4, that is equals to 0.10. From here you can directly calculate these things. 0.20 ln 0.20 divided by X2, that is equals to 0.10 divided by 4. So you can cancel it out finally, and you can get ln 0.20 divided by X2, that is equals to 1 upon 8. From here you can get 0.20 divided by X2 equals to e to the power 1 by 8. So x2 will be equal to e to the power minus 1 by 8 multiplied with 0.20. So let's try to calculate here. So finally the value of x2 you will be getting 0.1764. This is final moisture content and you are supposed to calculate in percentage. So you can write x2 will be equal to 17.64% only. Is that clear? Okay, so after that I'll be moving towards the next and last question. This question has been asked in GATE 2023 of 2 marks, and you can say that a wet air containing 10 mole percent of water vapor is dried by continuously passing it through a column. So let's say this column is there. So here wet air is going, column of CaCl2 pellets. So here there will be a CaCl2 pellet somewhere. So here wet air is being supplied, 10% water vapor is there. So in wet air you can see 10% water vapor and 90% dry air. Okay, so let's say if I am assuming wet air quantity is 100, so wet water vapor will be 10 and 90 will be your dry air. And once it is getting exited from the air, so here definitely you will be having water vapor, and again there will be dry air. So the pellet removes 50% of the water from the wet air. So let's say if water vapor here is 10 and it is removing 50%, right? So how much water vapor that has been left here? So water vapor that is there is only 5, and since dry air will be as it is, right? Dry air is not going to change because you are not removing the dry air. So the dry air that you are supplying here, that you will get here. So that is 90. So now you are supposed to calculate the percentage of water vapor at the exit. So what is percentage or mole percentage of water vapor? So mole percentage here, that is 5 divided by 95 5 divided by 5 plus 95, right? 5 is water vapor plus 95 is your 90 is your dry air, right? Into 100. So if you will calculate these things, you can get 5 divided by 95 into 100. So once you calculate these things, you will be getting 5.263 percentage. Okay, this will be your answer. Okay, so with that I'll end the lecture PYQ series of drying mass transfer, and after that I'll be starting with the absorption mass transfer, absorption and stripping, right? And after that I'll be starting with the fluid mechanics. Okay, so I hope all of these things are clear to all of you, and I request you to share this YouTube channel with among your colleagues so that it will reach to with most of the person who wants these things, that and who are not able to avail free lecture that is available on different platform also, right? Thank you.